Welcome. This video is CCBYNC. Glad to have you back. We are going to do some review as we start chapter 3, and we're going to go through some of the fundamental identities. I wanted to remind you that this is the unit circle, meaning the radius is 1. And the formula for this in algebra centered at this at the origin like this is x squared plus y squared equals 1 because the radius is 1. And you can see x and y are going to change all over the place depending where they are. Sometimes they're negative, sometimes they're positive. It just depends. So let's do a quick review. Our quotient identities. Sine of x is the opposite over the hypotenuse, which is also y over r based on this triangle here. And if it's the unit circle, it's just y because 1. Cosine of x is going to be the adjacent of the hypotenuse, which is x over r, which if r is 1, then x is just x. And tangent is the opposite over the adjacent, which is y over x, which is also sine of theta over cosine of theta. And I'll change those to thetas, which is, don't want to mix them up with these x's here. And those thetas. The reciprocal identities, cosecant theta is 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta, which is the reciprocal here as well. Theta over sine theta. Just to review. And we have an example here. We have the secant of theta is 5 over 3, and theta is in the first quadrant. That makes it nice and easy. Now, because secant is the reciprocal here, the numerator is the hypotenuse. And the denominator is x. So we are 3 down here, 5 here, and we're missing y. So y squared plus 3 squared equals 5 squared. Because we're in quadrant 1, y is 4. This means that sine of theta, theta's here, is the opposite over the hypotenuse. Cosine theta is the adjacent over the hypotenuse, which is 5. It's also the reciprocal there. I could have just flipped that upside down. And the tangent of theta is the opposite over the adjacent. We also have the Pythagorean identities. There are 3 of them. This is the main one. And you can see if we're having sine of theta is y and cosine of theta is x, then cosine squared plus sine squared is 1. And that's where that comes from. Now, if I divide through by cosine squared, I get sine squared over cosine squared. This becomes tangent squared theta plus 1. And 1 over cosine is secant. And if I were to divide through by sine squared, I would end up with 1 plus cotangent squared theta equals 1 over cosecant is, 1 over sine is cosecant. So here are 3 trig identities. Again, realistically, we use this one a lot. All right, let's do an example. We're going to use 30 degrees to show that sine squared theta plus cosine squared theta equals 1, that holds true. So I have my unit circle handy here. We'll be here at 30 degrees. Remember, x is cosine, y is sine. So sine of 30 degrees, which is the y coordinate at 30 degrees. So here we are at 30 degrees, that's 1/2. Cosine of 30 degrees, that's the x coordinate, √3/2. And so sine squared of 30 degrees plus cosine squared of 30 degrees equals 1/2 squared plus √3/2 equals 1/4 plus 3/4. And I have a common denominator already, which is nice. It gives me 4/4, which is 1. And so it has been shown. We are moving on to the next page. We're talking about even and odd identities. An even identity, an even function, pardon me, says that if I change the, take the opposite sign of x's and I go f of negative x, the even function absorbs it. Kind of like when you square a negative number, you end up with a positive number, right? -5 times -5 is positive 25. That's an even function. An odd function, it works opposite of that. F of negative x means that it's the negative of that function. Exactly the opposite happens. And you can see from here, they're exactly the same, but in opposite signs. Whereas here, regardless, negative x or positive x, it doesn't matter. They have the same y value. Now, I want to point out that sine and sine an odd function, and you'll explore that a little bit more in Calculus 2, those of you heading on to that direction. Cosine is even, and you can see sine of negative theta is negative sine theta. That's the definition of odd. Tangent is also odd. Cotangent also odd. Secant is even, not surprising since cosine is, and they're just reciprocals of each other. And cosecant is odd. All right, example 3. Let's see if I can keep that. That'd be useful. If tangent of theta is -1, then find tangent of negative x. Let's see what that looks like. So tangent of negative x is equal to negative tangent x. And since I know tangent x is -1, this becomes -1, or just 1. Sine of x is positive 1/2. Sine of negative x is negative sine x. And sine x is 1/2, so this becomes -1/2. And this is B. We'll do C over here. C. Cosine of x is equal to 0.3. And the cosine of negative x is equal, because it's even, 3. And for part D, so this actually is just because tangent is has a period of pi. If we add pi to x, then it's exactly the same. As far as the value goes. So this will also be -1/2. All right, example 4. Cosine of negative x is 3/4. Now that means that the cosine of x is 3/4. And this means that the tangent of x is negative tangent x. So this is negative root 7 over 3, just root 7 over 3. And I'd like to point out that on this triangle, because cosine by definition is the adjacent of the hypotenuse. And if we use the Pythagorean theorem, we end up with this here. So finding the sine, this is our x, finding the sine here is going to be the opposite over the hypotenuse. So sine x is going to be the opposite, which is root 7 over 4. Not too difficult, I'm hoping. Here's our cofunction identity. So as I've mentioned before, each of the cofunctions are just 90 degrees phase shifts of one another. And we explored that a little when we were doing the graphing in the graphing videos. So I'm going to notice cosine of pi over 2 minus x. That is sine of x. So we know that sine x is equal to 4 over 5. Because cosine of pi over 2 minus x is sine x. So sine of negative x is the same as negative sine x, which becomes a negative 4 over 5. So some of this was review, some of it was a little bit new, but nothing too debilitating or anything. Thanks for watching.